Welcome back to the next lecture in the lecture series on quadratics. I hope you have seen my first lecture. If you haven't visited, go onto my channel and see the very first lecture that I recorded a few days back on how to find or how to make completed the square form of a quadratic function, which has got many applications, and we are going to start those applications from now. So the very first application that I will mention is getting the vertex of a parabola. You know, the parabola is the shape that we get when we graph a quadratic curve. Any quadratic curve of the form ax squared plus bx plus c will give us a parabola, right? And we need to find the vertex of that parabola using the completed the square form. So let us look at the completed the square form again and see how we can get the vertex of that parabola, and that has got many other applications going forward. So we had looked at, let's say y is equal to a times x minus h whole square plus k, right? Or it would be negative a x minus h whole square plus k. You cannot get any other form of the completed the square form. Either the completed the square form will be of the type 1 or type 2, right? What is the difference? In type 1, this coefficient a is positive. And here we have got what is called minus a, which means that we have something like minus 3 times x plus 2 whole square plus 3 or something. So this coefficient here is negative. Whereas in the first form, the coefficient a is going to be positive, right? So I will be very clearly differentiating between the two and then tell you how to look at the vertex from this. Now, if this is the form, either the first or the second, the vertex of the parabola is given by h comma k. You have to remember that we have to have x minus h, please, plus k. Or here also you can see it is minus h plus k. That is very important, that we should have negative h. Then we have the vertex as h comma k. This does not make any difference to the vertex. This makes a difference to the shape of the parabola, but this doesn't make any difference to the coordinates of the vertex. So one of the first application of or useful thing that comes out from the completed the square form is that we are able to read the vertex of the parabola. So let me take some example now and then we'll see how we can. Let's say first example is, let's say y is equal to 2 times x plus 3 whole square plus 5. Now the vertex of this parabola is going to be, it is x plus 3. So we should be writing it as x minus 3 whole square plus 5. And therefore the vertex is negative 3 comma 5. Please compare with the standard form of the completed the square form. And here we have seen this is negative 3. So we have to write x minus h. Whatever comes here becomes the x coordinate of the vertex, and whatever is outside this square term, which will be a constant like plus 5 or whatever, will be the vertex or the y coordinate of the vertex. Then let's take the second example here. Let's take y is equal to negative 3x minus 4 whole square minus 5. See, if I take this example now, the vertex is very clearly now it's x minus 4 already. So we'll have 4 as the x coordinate of the vertex and negative 5 as the y coordinate of the vertex. All right, I hope this is very clear now. So we get the coordinates of the vertex by writing the completed the square form. We can get otherwise also. But once we write these forms, either the form 1 or the 2, directly we can read, or one can read directly from this completed the square form, the coordinates of the vertex. Now, what is the role of this plus 3 or plus 2 or minus 3? Let's look at that also. Whenever a is positive, that means whenever we have something like 2 times x plus 3 whole square plus 5. This is the first one I used. Here a is 2. It is positive. Then the parabola will be like this. So this vertex that we wrote, -3, 5, would be a point which is the giving us the minimum value of the function. So the minimum value of the function is 5 at x equal to -3. So once we are able to get the coordinates of the vertex from the completed the square form, immediately we can get the minimum value of the function. Minimum value of the function is the y coordinate, not the x coordinate, because y is the function value. So minimum value of y is 5 at x equal to -3. And if the parabola is of the second form, like the example that we took, -3x minus 4 whole square minus 5, then what's happening here? We said the vertex is 4, -5. Now here the a is negative. So it's going to be a parabola like this, where the coordinates of the vertex are 4, -5. So this becomes now the maximum value of the function. Maximum value of the function, therefore, is -5, and it happens at x equal to 4. So immediately from the vertex, one can say about the shape of the parabola and also tell whether the graph has a maximum value or the minimum value. Number one. Number two, what is that maximum or minimum value? That also we can get from this form. Also, we know the x value at which that maximum or minima happens, isn't it? So it's very clear that whenever we have y is equal to a x minus h whole square plus k, vertex coordinate will be h comma k, and if a is positive, then y equal to k is the minimum value of the function. Correct. And if it is y equal to a x minus h whole square plus k, vertex is again h comma k, but if a is negative, then y equal to k is the maximum value of the function. And we also know the x coordinate of the vertex, which is a very important, again, one of the very important ideas is to get the x value of the vertex, because that helps you to do many other things. So let's take some one or two examples now and then finish this. So let's take this first. Let's say I give you y equal to -2 x plus 3 whole square plus 5. So the vertex is going to be -3, 5. It is x plus 3. So vertex is -3, 5. The shape of the parabola is going to be like this because a is negative. And the maximum value of the function is 5 at x equal to, and value of x is equal to -3. Okay. So the value of x is -3, then y is equal to 5, and that is the maximum value of the function. Now the function cannot take any value more than 5. You can see the both sides of the value, y values are becoming less than that. This is the maximum value. And if I take another example, let's say y is equal to 5 times x plus 4 whole square plus 10, then the vertex coordinates are -4, 10, and we will have a parabola which will have a minimum value, right? And the minimum value of the function is going to be 10. So minimum value of the function is 10. And x coordinate of the vertex is -4. Right? I hope this is very clear. And I hope to continue with this and also give many other applications of the vertex. Even vertex has many applications. We can reduce the function to a one-to-one function, right? And we can define the domain of the function so that the function can have an inverse. All those things will come only after we have very good with this. So please share the video with all your friends, like and subscribe. and I'll continue with the other videos which is coming up now. There was some glitch happened because of which I could not make the videos in the last week, but now I think things are very smooth and hope to make the videos very regularly. As I said, all the details of my contact are available in the description box. So students can contact me on that telephone number and email ID. And if any particular topic is there where you want me to make the video, it will be my pleasure to do that. Thank you.